For this warm-up, you need to either add or subtract. With addition and subtraction, your decimal places need to be lined up. So for example, in problem 5, we could do 5.60 and 4.72 so that our place values are aligned with their decimal places. 0 plus 2 is 2. 6 plus 7 is 13. 1 plus 5 is 6. Plus 4 more makes 10. And our decimal place needs to be aligned as well for 10.32 as our answer. Subtraction also needs your decimal place lined up. You can add a 0 to the end of a number to help align those numbers. So you're planning a trip to Mars, and you need to think about what resources you might want to take with you, depending on how long you are there, what resources might be available on Mars, and what things we would need to bring from Earth. So depending on where you are at in the orbit, your distance from Earth to Mars is going to change. In problem 1, it says, consider the following information. The closest distance from Earth to Mars is about 34.8 million miles. But the farthest distance between Mars and Earth in our orbit would be about 250 million miles. The speed of light, which is how fast light can travel, is about 186,000 miles per second. How many minutes will it take your message to get from Mars to Earth when the two planets are as close as possible? Round your answer to the nearest hundredth. So this is if our message is traveling at the speed of light. I'm going to solve this on a different slide, and then we'll write our answer here in part A, just so I have more space. The closest distance is 34.8 million miles. So 34 million would be with 6 zeros, but it's 34.8. So this one is going to be an 8, and we're splitting it into 186,000 because that's how many miles it can go each second. We can simplify this problem by eliminating tens. If I divide both by 10, or 100, or 1,000, now my problem is 34800 divided by 186. It just reduces the amount of digits I have to work with. I'm going to keep a list of multiples of 186. 8 plus 8 is 16, plus 1 more is 17, so that's 372. So since it's 380 and 48, I know that only one of them can fit in. And I'll subtract. 8 minus 6 is 2. Regroup. 14 minus 8 is 6. 2 minus 1 is 1. Bring down a 0. Two plus 6 is 8. 3 plus 8 is 15, or 7 plus 8 is 15. 1 plus 3 plus 1 is 5. Plus another 186. 8 and 6 is 14. 8 plus 5 plus 1 more makes 14. 1 plus 5 plus 1 is 7. Four and 6 make 10. 8 plus 4 plus 1 more is 13. 7, 8, and 9. So that's 1, 2, 3, 4, 5, 6, 7, 8 that fit in there. And the eighth one is 1,488. I'll have to regroup. 10 minus 8 is 2. That became 1. I'll regroup again to turn it into 11. 11 minus 8 is 3. 5 minus 4 is 1. And 1 minus 1 is 0. 1,320. That's 1, 2, 3, 4, 5, 6, 7 can fit in there. 10 minus 2 is 8. 1 minus 0 is 0. Bring down a 0. None can fit in there. 9 can fit in there. The ninth one is 1,674. 10 minus 4 is 6. 9 minus 7 is 2. 7 minus 6 is 1. Bring down another 0. 1, 2, 3, 4, 5, 6 of them can fit in this time. And we're still going to have a remainder, but it asked us to round to the hundredths place. So we had to go to the thousands to be able to determine if this thousands place makes the hundredths round up or stay. So this rounds to 187.10 because the 9 is going to turn into a 10. But if you notice, this was in seconds, and it asked for our answer in minutes. So to turn the seconds into minutes, we need to divide by 60. So it can fit into 187 3 times. It can fit into 71 once. It can fit into 110 once. 11 minus 6 is 5. Bring down another 0. That's 1, 2, 3, 4, 5, 6, 7, 8 times. And if we're rounding to the hundredths place, the 8 makes the 11 turn into a 12. So 3.12 minutes. Part B says, how many minutes will it take your message to get from Mars to Earth when the two planets are as far apart as possible? Round your answer to the nearest hundredth. So we're looking now at the 250 million split into 186,000 miles per second to figure out how many seconds, and then we'll convert it to minutes. Remember, we can eliminate tens to work with smaller values. So 186 fits into 251 time. 10 minus 6 is 4. 14 minus 8 is 6. Bring down a 0. That fits in 3 times. The third multiple of 186 is 558. 10 minus 8 is 2. 13 minus 5 is 8. Bring down another 0. That's 1, 2, 3, 4 that can fit in. 10 minus 4 is 6. 11 minus 4, 7. That fits in 4 times as well. 10 minus 4 is 6. 5 minus 4 is 1. Bring down another 0. 186 does not fit into 160, but it does fit into 1,600. 1, 2, 3, 4, 5, 6, 7, 8 times. Ten minus 8 is 2. 9 minus 8 is 1. 5 minus 4 is 1. Bring down another 0. 1,120 divided by 186. That fits in 1, 2, 3, 4, 5, 6 times. That rounds to 0.9 because the 6 makes it go up. And now we need to change it from the seconds into minutes. So to change it to minutes, we need to divide this by 60. 60 doesn't fit into 1 or 13, but it does fit into 134. 2 times. That leaves us with 14. Bring down the 4. It also fits into that 2 times. It fits into 240 exactly 4 times. It does not fit into 9, but it does fit into 90 once. But that can be changed to 22.4 because the 1 makes it stay, and that is in minutes. Suppose Mars is at its farthest distance from Earth, and you send a message to the person, and they respond immediately. How many minutes would it be before you get a response back? So you sent it. It took 22.4 minutes to get there. They respond immediately, and it takes 22.4 minutes to respond back or to return back. How long will it be since the time you sent that message? Well, it's 22.4 to get there and 22.4 to get back. Four plus 4 is 8. 2 plus 2 is 4. 2 plus 2 is 4. So it would take 44.8 minutes. Use your answer from part C to determine how many messages you can send and receive in 12 hours. Well, it takes 44.8 minutes to send and receive a message. This is in hours, so we need to convert it into minutes. 12 times 60, because there's 60 minutes in an hour. 12 times 6 is 72, so 12 times 60 is 720. That is how many minutes, and this is how long it takes. So let's go and do the math on the next slide, where we have some room. Remember, we want to work with division of whole numbers. So we're going to move this decimal once and move this invisible decimal once as well. So they're both whole numbers. Now I'm working with 448 and 7,200. Well, 448 fits into 721 time. 10 minus 8 is 2. 11 minus 4 is 7. 6 minus 4 is 2. Bring down that 0. That's 1, 2, 3, 4, 5, 6 of them. 10 minus 8 is 2. 11 minus 8 is 3. 6 minus 6 is 0. 2 minus 2 is 0. Now, in this one, it just asks how many we can send and receive. So we're going to use a whole number, and we can only send and receive 16. Regardless of what this is going to come out to, the decimal will continue beyond that. But the maximum amount we can send is this 16. For problems 2 through 5, consider the following situation and information. You plan to stay on Mars and send a shuttle to Earth to gather food, water, and oxygen. It takes about 2 years for the space shuttle to go to Earth, gather supplies, and then come back to Mars. An astronaut breathes about 613.2 kilograms of oxygen in 2 years. An astronaut needs about 25.9 liters of water each week to survive. An astronaut eats about 1.27 pounds of food each meal. Number 2, how many kilograms of oxygen do you need for 1 day? So it told us how much oxygen they need for 2 years. Well, in a year, there are 365 days, and we have 2 years. 300 times 2 is 600. 60 times 2 is 120, and 5 times 2 is 10, so this would be 730 days. So we need 613.2 split up amongst the 730 days. 730 doesn't fit into 6, 61, or 613. Let's create our list of 730s. So here's my list of the multiples of 730. It only fits in 8 times. That's 5,840. Bring down a 0. That's exactly 1, 2, 3, 4 of them. So there's going to be no remainder. Number 3, there are 52 weeks in 1 year. What is the least amount of water in liters you need to survive on Mars for 2 years? Well, this is a week. There are 52 weeks in 1 year. So we need 52 times 2 because there's 2 years. 2 50s is 100. 2 2s is 4. So that's going to be 104 weeks. And we need 25.9 each week for 104 weeks. That's going to be a multiplication problem. We don't know the total oxygen, or the total, water. 4 times 9 is 36. 4 times 5 is 20, plus 3 more is 23. 4 times 2 is 8, plus 2 more makes 10. This is going to be a whole row of zeros. And then we'll need to put in 2 place value spacers to work with this 1 here, since it's now in the hundredths place. 1 times 9, 1 times 5, 1 times 2. Add that all up. There's 1 decimal spot in our question, so we need 1 in our answer as well. (2,693.6 liters of water. Or assume you eat exactly 3 meals each day. About how many pounds of food would you need to survive on Mars for 2 years? This is per meal, and we need 3 meals a day for 2 years, which is 730 days. Zero. 3 times 3 is 9. 3 times 7 is 21. So we have 2,190 meals in 2 years. And each meal is 1.27 pounds. 7 times 0. 7 times 9 is 63. 7 times 1 is 7, plus 6 more makes 13. 7 times 2 is 14, plus 1 more is 15. Put a spacer. 2 times 0 is 0. 2 times 9 is 18. 2 times 1 is 2, plus 1 more makes 3. 2 times 2 is 4. Now put 2 spacers. Oops, I wanted to change it to green. 1 times 0 is 0. 1 times 9. 1 times 1, and 1 times 2. Add them all up. There's 2 decimal spots, so I need 2 here as well, for 2,781.3 pounds of food. Consider the additional information. 1 liter of water is a kilogram, and 1 pound is approximately 0.45 kilograms. What is the total mass in kilograms of a 2-year supply of food, water, and oxygen? Round your answer to the nearest hundredth. Well, let's start by changing the pounds of food to kilograms. We're going to have to multiply that by 0.45. Five times 3 is 15. 5 times 1, 5, plus 1 more, 6. 5 times 8 is 40. 5 times 7 is 35, plus 1 more makes 39. 5 times 2 is 10, plus 3 is 13. Put your spacer in there. 4 times 3 is 12. 4 times 1 is 4, plus 1 more is 5. 4 times 8 is 32. 4 times 7 is 28, plus 3 is 31. 4 times 2 is 8, plus 3 is 11. There's 1, 2, 3 spots. But it also asks us to round. So this is 1,251.59 for the food. Then we need the water and the oxygen. And the oxygen is 613.2. We can put zeros in there since we're adding just to help us keep it lined up. 9 plus zeros is 9. 5 plus 6 is 11, plus 2 more is 13. 3 and 3 is 6, 7, 8. 9 and 1 is 10, plus 5 more is 15. 6 plus 6 is 12. 13, 14, 15. 2 plus 1 plus 1 is 4. So this should be 4,558.39 kilograms. Suppose it costs about 20,000 to send 1 kilogram into space. Use your answer from part A to determine about how much it will cost to send a 2-year supply of food, water, and oxygen for one person into space. Okay, well, we're going to just multiply by a bunch of zeros to get a whole bunch of rows of zeros, which isn't super helpful. But we know that we need 1, 2, 3, 4 spacers to start. Then we're going to multiply by 2. 2 times 9 is 18. 2 times 3 is 6, plus 1 more makes 7. 2 times 8 is 16. 2 times 5 is 10, plus 1 is 11. 2 times 5 is 10, plus 1 is 11. 2 times 4 is 8, plus 1 more makes 9. Then we have 2 decimal spots, so we need 2 decimal spots here as well. So 91,167,800. So this is just a lot of practice working with decimals, multiplying, adding, dividing, just as a kind of wrap up to the module. So keep in mind with multiplication, you need to count how many decimal spots there are in the question and duplicate that in your response. With addition, the decimal places have to be lined up. And there's some little tricks you can use for division to either move the decimal the same number of spots to make them whole numbers or to make the numbers smaller to work with.